So we're now at the control board in the air handler unit, and so I've got my 18.7 thermostat wire right here that is connected to the terminals. So my brown wire is going to W2, my yellow wire is going to Y, my green wire is going to G, my orange wire is going to this O/B, my white wire is going to W1, my red wire is going to R, my blue wire is going to C, and then from the condenser unit outside, we've got our S1 and S2 communication wires. So S1 and S2 are, this is a stranded 18.2 shielded wire. So I'm using the stud spade end crimp terminal connectors here, so that's we're making sure that we maintain good contact for these two guys. And then this is my power. For this unit, it needs a double pole 15 amp breaker to run the indoor or the air handler unit, and so I have the blue, which is the appropriate size for the 14 AWG copper wires that I have for phase A, phase B, and ground, going to L1, L2, and ground on the terminal block right here. So that is the wiring setup. And then for my condensate float switches, so I've got one on the overfill port and then one on my T and my P trap. So both of these guys have two wires that go up. The white wire is that COM, that 18.2 S1, S2 wire, and then these two blacks are the float switches. So these guys come up here, there's my thermostat wire, and then they come into a, put in a little plastic clamp right here just to protect them from getting cut on the metal. They enter into this part of it, and then I'm gonna have, so with those float switches, they're gonna cut power at the red wire. So if you trace this red wire back to here, I have a lever nut that goes into the first switch. So this is one of those switch wires that goes into the other switch wire right here. And then finally from that other switch wire, it goes to the original red connector here. So that's how you interrupt power if there is a clog down there. So what happens is the power, even though it's trying to come in here or go out there, it has to pass through both of my switches. So both switches have to be in the no leak state, which is the on state. And if either switch or both of them are detecting leaks, then they cut the power. So then this connection from here to here gets cut, and that'll stop the unit from working. So this is the outdoor condenser unit, and this is the wiring. And so this is L1, L2, so your two hots. In my case, I have a 30 amp 2-pole for that, and then my ground. And then on the end of each one of these, you'll note how, because this is 10 AWG wire, I have a spade fork on it, a terminal crimp connector, and it's insulated so that we get full contact. If you didn't have these and you just put the stranded copper into those terminals, that's not a great way to do it. And then for the communication wire right here, this is 18.2 shielded wire. That's what that silver stuff is. Has a ground in it, so you're only supposed to ground one side of it, so I'm grounding it here at the condenser. And then I've got S1 and S2. You can just barely see that S1, and then S2 out here connecting this. This is how the condenser is going to talk to the air handler inside the house. And the way this cover works is there's 4 screws, and so it goes in, and these tabs tuck up underneath there to get you a seal. So don't know if I can do this one hand, but we'll see. Something like that. So I'm going to screw those guys, these guys, and then I'm using 1/2 inch because they provide 1/2 inch knockouts on this thing. Unfortunately, there's no 3/4, but these 1/2 inch flexible PVC conduits is just providing additional protection for my 18.2 COM wire, and then my power for that 30 amp to pull off this non-fused disconnect.